Alright, in the last video we got up to this point with this molecule where we first identified the chirality center, and then we gave priority to each of the groups attached to the chirality center, and then number 3, we rotated the lowest group away from us, and then step 4, we saw which was it clockwise or counterclockwise. I've built a model of this to kind of illustrate here. So this is the same thing that we have up here. We have our OH, our hydroxyl group, at the top, our chirality center right here in the middle. We have our CH3 right here, our methyl group. Back here where I'm holding, we have our H, and right here we have our ethyl group. Can't really see that. You can see there's your ethyl group. There's a CH2, CH3. Okay? So there's a lot of different ways you could look at this. You could look at it where I'm looking dead on at the OH and so on and so forth. But when I said step 3, we rotated the lightest or the lowest priority away from us. What I'm talking about is, here's my chirality center, and I've identified that the H is the lightest of all of these, this lone hydrogen right here. And so we could think about it like grabbing the H and then rotating it away from us like that, so that that's pointing into the page. And now you can see that this all matches up. So we have the CH3 right here, the CH2, CH3 right here, and the OH sticking up right here. And I went ahead and drew it out this way to begin with. But when you start doing problems, they're not always going to be drawn this way. And you're going to have to either rotate it in your mind or draw it out on the page a different way. We'll get into how to do that. There's a few tricks of the trade that you could learn to do that. So once we've rotated the least priority away from us, then we count from the highest priority to the least priority. And that was, we found that OH was the heaviest, and then the ethyl group, and then the methyl group. And since I'm looking at that, that's in a clockwise direction, that gets R for rectus or right-handed. So this gets, the configuration is R for this. Now, when it comes to naming this, first thing we got to do is name the actual compound. And I haven't put on how to name organic compounds on any of these, but if you're looking up stereochemistry, then you should have a pretty good idea of how to do this anyway. So real quick, I'm going to just look at the molecule that we have here and count the carbon chain, right? So we have 1, 2, 3, 4 carbons. So that's going to be but something. And I see that we have a hydroxyl attached to the second carbon there. So that's going to be a 2-butanol of some kind. So that's 2-butanol. But since there's a stereo center, right, or a chirality center on this molecule, we have to designate, is it R or S? And we went through all of that. And so the way that you would write this down, the name of this molecule would be R-2-butanol. And let's see. Yeah. Okay. So, just to illustrate now, let's say that I swap 2 of these guys out. I'm just going to relocate 2 of the groups to other places here. Okay, all I did was swap the H with the CH3. Okay, and now we can look, we have, it's still a butanol, it's still 2-butanol, right? We have 1, 2, 3, 4 carbons, so that's going to be but something. And since this is attached to the second, it's going to be 2-butanol, right? Since it's a hydroxyl attached to the second carbon, it's a 2-butanol. But now let's do the same thing. Let's identify the stereocenter, and that is this one right here. And now, of course, the priorities are the same. The H is the lightest. This is the heaviest. This is the second heaviest. This is the third heaviest. So I'm going to grab the lightest of the substituents, which is the hydrogen, rotate it away from me, and now I'm going to count from the heaviest group to the lightest group. And again, the OH is the heaviest, and then it's the ethyl, then it's the methyl. And so now this is going in a counterclockwise direction. And since it's counterclockwise, it gets S. We say S for sinister, or left-handed. S, I think, is Latin for, or sinister is Latin for left-handed, so S. Yeah. And so you could think of that as a left-handed turn, or whatever. So you can see that these are not the same molecules here. They're stereoisomers of each other. And in fact, they're enantiomers, because this, the S2-butanol, is a mirror reflection of the R2-butanol. And let me show you what I mean by that. So if we line this up, if we line the ethyl group up with the hydroxyl group here, and then if you look, you have pointing into the page, we have our methyl group, and pointing out of the page, we have our hydrogen, which is a reflection, a mirror reflection of what we have going on right here, where the hydrogen is pointing in and the methyl is pointing out. So you could, building models really helps with this. So if you were to build R2-butanol and S2-butanol and hold them right next to each other, you'd see that they're mirror images. And since they're mirror images, then they're enantiomers. So this is the very beginning introduction to naming using the RNS system. We're going to go through a lot more examples with this.